This is question 18 on chemistry from the 2014 BMAT. So we're told that an organic compound contains 6 parts carbon, 1 part hydrogen and 8 parts oxygen by mass, and that a 6 gram gaseous sample has a volume of 2.4 decimeters cubed at room temperature and pressure. So what is its molecular formula, given the relative atomic masses and that 1 mole of gas occupies 24 decimeters cubed at this room temperature and pressure? So where should we start with this? So the question talks about temperature, pressure and volumes of gas. So we should probably be thinking the ideal gas equation will come in at some point, which I always remember as PV is nRT. But because we're using volumes, maybe we should rearrange it to V is nRT over P. So what else should we use? Well, we're told that 1 mole of gas occupies 24 decimeters cubed at room temperature and pressure. And so if you put that into this, where n equals 1, we can say that RT over P is equal to 24 decimeters cubed. That's with room temperature and pressure, which we're using throughout the question. So we're also told that a 6 gram sample has a volume of 2.4 decimeters cubed. And so how can we use this? Well, we could use what we have already to work out how many moles this is. How do we do this? So we have the volume, and we know what RT over P is, so we can work out N by rearranging the equation like so. So we have V divided by RT over P, and putting the numbers in gives 2.4 decimeters cubed divided by 24 decimeters cubed, which comes out as 0.1 moles. So for this sample we have its mass and how many moles it is, and so what's the next logical thing to work out? So we're going to need the molecular formula, so we should probably work out the relative molecular mass. And how do we get this? So we know number of moles is mass divided by the relative molecular mass. So let's rearrange it for MR, which gives mass over number of moles. So putting the numbers in gives 6 grams divided by 0.1 moles, which of course is 60 grams per mole. So we have the mass of one formula unit, and we know how it's divvied up by mass as 6 parts carbon, 1 part hydrogen and 8 parts oxygen. And so what do these parts mean? So if we take the 60 grams and divide out how many parts there are, then we could find the mass of one part, which is 60 divided by, so 6 plus 1 plus 8 is 15, which is 4 grams for each part. So knowing this, we can work out exactly how much carbon, hydrogen and oxygen is in it by timesing this part by how many parts there are of each element. So for carbon, we have 6 parts, they're each 4 grams, so that's 24 grams of carbon. Hydrogen, there's just 1, so that's 4 grams. And oxygen, we have 8, so that's 32 grams. So we have the mass of each element inside 1 mole. So what would help to work out now? If we knew the number of moles, then we'd be able to work out the molecular formula. So how many moles of carbon are there in each formula unit? Well, we can use this formula, but replace relative molecular mass with the atomic mass that we have here. So we know the mass of carbon, we know its relative atomic mass is 12, so let's put the numbers in. We have 24 over 12, which gives 2 moles. And for hydrogen, we know the AR is 1, so we have 4 grams. So putting the numbers in gives 4 over 1, 4 moles. And finally for oxygen, we have 32 grams over 16 grams per mole, which is again 2 moles. So in each formula unit, there are 2 moles of carbon, 4 moles of hydrogen, and 2 moles of oxygen. And so what does that mean for the molecular formula that we need? So we can just use these numbers. We have C2H4O2. So that is our final molecular formula, which corresponds to answer B on the question paper.